Good morning, everyone. So around 14 students online right now. Okay. So how about last session? What we have seen? The last session? Hmm? Bubble sort. Only bubble sort? We have seen something else. Insertion shot and selection shot is not. We didn't do. Okay. Hmm? Yeah, one bubble sort, right? So bubble sort is simple. You just want to keep comparing that, first element with the next element, adjacent element. That's then if it is less than, this comparing element, left element, then you just swap, right? If it is greater than, then you just have it. I mean, you can compare based on the condition. So if it is 50 and the next element is 40, then swap. If it is greater than, then don't swap. Go to the next. Then so you will start from the left, and then you have to keep on going. Then once you complete the first, pass, then that is called the first pass. Then do the next step. I mean, second pass, third pass. It keeps on going like that. So we have seen that it's like if you have n number of elements, then if you have to do n minus one, swaps. I mean iterations basically. Okay. So the next thing is we will talk about insertion shot. Okay. Switch it on. Because I didn't share anything right now. I'm just discussing. Can you switch it on? But why these remotes were not working? Yeah. Yeah. So today we will talk about two types of sortings. One is insertion sort and selection sort. Insertion sort is not there in the syllabus, but we will learn how it is because it's very simple. Um, then we will talk about selection sort. Okay, that's very easy again. I'll let you know the differences between these two. Insertion sort. Have you heard about that? Hmm. So let me share my screen first. Okay. So this particular table, time complexity table is very important, right? Uh, at least you should get to know for the first four things: quick, bubble, insertion, and selection. Yeah, first five things, including merge, right? So merge sort is not there. We have these four types of sortings in your syllabus: bubble, selection, quick, and merge. Insertion is not there, but we will learn it. Okay. I mean, it's required when you go for selection sort so that we can compare the differences. Okay. So insertion shot is something related to your card game. We used to play cards. We used to arrange cards, right? So how we will arrange cards? You have three cards in your hand. Let's say three cards. The first card is number one, and the second card is number two, and the third card is number four. 1, 2, 4 is there. I'm giving you one more card for you that has number 3. So now where you will insert this card? So between 2 and 3. So which means first you will check like which is less than or greater than of this element or what, this or what. Then you will put it in. You will insert that card right on the appropriate place. So that's how insertion short works. Uh, I have an example. So basically, we will have. I said that you will be having 3 cards in your hand. So all these cards which you have in your hand will be arranged. I mean, first it will be not arranged. Then you will arrange it. Then whenever the next card, unsorted, I mean, some random card comes to you, then you will put it that one. You will place that one in a proper order. Is it? For example, you have 5 cards. Those are all like 1, 2, 3, 4, 5. 5 numbers. I'm just saying. I'm just giving numbers. Like 1, 2, 3, 4, 5. If next card comes, that is number 6, then you will put it here, right? If it is 0, then you will insert it here. I mean, based on the comparison, you will, right? So if any number is missing, then for example 3 is not there. You have 1, 2, 4, and 5. The upcoming card is 3. Then you will. So these the left side will be sorted. Nah? This 1 and 2 is already sorted. Then the right side thing is not sorted. So you will sort it in that way. So what do you understand from this? I have a sequence of numbers 4, 3, 2, 10. So that is the question. 4, 3, 2, 10, 12, the first row. Okay, so these are all the some random numbers given to you. So how do I sort first? So what I do is that first I will take this 4 number. I will take one number as sorted, already sorted. I'll take like that. So I will draw a line, and then in the left side, I mean left side of 4 is sorted, I will say, and then this is unsorted array, right? Then what I do is that I will compare. I said that I will draw a line here after 4. Then I'm saying that the left side is sorted, and then right side all the elements are unsorted. Then I'll compare the first element with the index number 0. Then here in the index number 0, what is the element present? I mean, we have 4. This is 0, 1, 2, like that. Huh? I mean, in array, I'm talking about, right? So I'll compare with 3. Then it is less than the sorted element, which means I need to swap. So I'm performing swap here in the next step, right? I mean, here I've taken the question. I've written the question again, which means here I have highlighted that I'm going to compare 4 and 3. So 3 will come here, and 4 will replace the position of 3, and then the rest will be the same, right? Now you see this. I said that first I will draw a line here after 4. Then now I will draw a line over here. Means one side I will keep on incrementing my loop, because I don't want to compare again 3 and 4. Right? It is already sorted, right? So now there will be a line. Then here it will compare. So while comparing, this is important. You will compare with from the left side. First, you will compare with 4, whether it is less than or what? Less than or what? 2 is less than 10. Okay. Yes. Then again, yes, it is true. I mean, this is how your for loop works, right? Then again, it will compare the next index. So it compares with 3. What happens? Again, it is less than, right? So it will swap. So which means that it will swap this one, but it will put this one in the index 0, and then this will be changed to index 1. So yeah.
The second will go first before the 4, then before 3. Or it will directly go to.
No, first it will compare here. From here it will compare with 4 first, then 2. Then it is sorry, then 3. Then again it is less than, so that this 2 should go here only. So that will be replaced, right? So likewise it keeps on comparing. So don't compare it from here. Starting 2 will be compared directly. No, it will be compared from all these elements, right? So let's do an example so that you can understand this better. So let me just write a sequence. So yeah, I have 5, 4. Am I audible to these guys? Sometimes. Okay. 10, 1, and 6, 2. So what should I do now? So I will say, I said that for my reference, I will just take this as sorted. The left side is sorted one, like sorted list. Then this is unsorted, okay? I mean in the right side. So now what should I do in the first step? Yeah, so I'll just compare these two things. So what should be done in this case? Yeah, 4 should be swapped to 5. But in programmatically, now we will swap it like this. But in program, we need a temp variable because, yeah, so we will say temp t. So now I'm comparing 4 with 5, right? So it is less than the, the number 5. So it should swap, right? So while swapping, what happens? I know that 4 should be swapped. So 4 will be assigned to temp here. Then this place will be empty because I need to free something, then only I can insert. So now I will transfer 5 to here, this empty space. Then now in temp, what is the value stored? 4 is stored. Now I will replace this value to this index. So in program, it will replace like this only. You can't directly, clear a memory and insert something. You can't do that, right? So, which means that always you need a variable. I mean, you need a temp variable where you can store that particular element which is going to be swapped so that it can be done. 5 and 4, how will be swapped? Yeah, same condition. I mean, in bubble sort we have done, but here we need one more extra step. Like we have to compare, because once you got a lot of elements here, then you need to traverse that one in the left side. So one side, in one for loop, you have to keep on incrementing like this, because you have to keep on comparing upcoming elements, right? In one thing, you will decrement it. I mean, from here you should keep on comparing in the left side, so that one will be like sorted list. I mean, one for loop will be used for unsorted list. I'll show you the logic. Okay, so now what happens here? So I said that there will be a question mark, which means 5 will be replaced here, and then 10, 1, 6, 2. So now what will be replaced in this question mark? 4. So now the temp value will be replaced here, right? Yeah, that is 4. So this is how you need to mention steps. So this is done. Okay. So now we have swapped 5. Why I have marked question mark here? Because I want to show that how I'm replacing, right? That's it, nothing else. So now we have swapped 5, right? So now here this is already sorted. Now 4 and 5. It is arranged in ascending order, right? So now I need to compare a 10. So what should I do? Uh, 10 will be compared with 5. Then what happens? Do I want to swap? So while comparing this one, 5, should I compare again with 4? No need, right? Because so here we are minimizing one step. I mean, you can compare also, but it's waste of time. It will take a lot of time, maybe a few seconds, right? So which means it increases the complexity. That's why we are calculating time complexity of these algorithms: best case, worst case, average case, right? So we can minimize that. So because this is already sorted, 10 cannot go somewhere here, because I will compare with the first element. This is 10 is greater than 5. So let's put this one here itself, right? Then what should I do? So I will just replace. Now we have compared 10, right? So that is done. So I'll say that in the next step I need to write this, right? Yeah. So now what should I do with 1?
We compared with 10.
Then?
Compare with 5 and 4.
Yeah. So in the first step, what will happen? I will compare with 10. Yes, 10. I mean, 1 is less than 10. So that there needs to be a swap, right? So I will remove 1 here, right? Then what happens? In the next step, I will just say here there will be a question mark because 10 will be shifted here. 6, 2, right? In the temp, what is there? 1 will be there. I want to replace here, but what I do, I said that we need to keep on comparing. I won't replace it here. What I do here, I will again compare with the next element. I mean, in the left side, right? So 1 is compared with 5. So what happens?
So swap will be not performed.
No, it will be there in the temp only, right? Yeah, we need to perform swap. That is, we know that I can write it in one step, but you know how this 1 should be here, na? This 1 should come here, no?
Just asking about 10 and 1.
No. Swap will not happen because there are other elements. Whatever the elements, it should be compared if the condition is true. If it is false, see here it is false, na? We are not comparing to the next element because it is already greater, right? But here it is less than. I mean, the 1 is less than these elements, so it should keep on going. So whenever here the condition is false, then we will perform swap. So what will happen in the next step? Yes, I'll be comparing with 5, right? Again, the condition is true or false. You know, this 1 is less than 5, so there needs to be a swap. So in that case, what happens? Again, 4. So here 5 will be replaced here, right? Yeah, 10 and 6 and 2. Again, there is still one more element in the index, right? So now what I do? Again, I'll compare. Again, it is less than 4, so it should be swapped. So in this step, 4 will come here. I'm just showing how your in program it will be performed, right? Now again, there is no such element in the index. Okay, this 1 will be replaced here, right? So now 1 comes here, 4, 5, 10, 6, 2. Is this step clear?
Yeah.
Why I'm marking this because I want to show how it is shifting, right? So now what we have done, we have started comparing with 10. Now you see this 1, 4, 5 and 10 isn't sorted. So I will draw a line here. In the left side it is sorted, the right side it is not. So now I'll compare with 6. 6 will be compared with what? 10. So what should I do? Yeah, the condition is true, right? So which means that 1, 4, 5, there will be a question mark. So in temp 6 will be, right? So I will read first. I'll put 10 over there. Then what happens? Yeah, because there are other elements also. I can't directly replace. So I'll compare with 5. So now what happens? 6 is greater than 5. It's false. So
Swap will be performed with 10 and 6.
why 10 and 6?
6 will replace the 10. Yes, the position of 10.
So now I have replaced 10 over here, na? Then
So the value will be equal to 10.
yes. So 6 is inserted here because the condition is false here, right? So 1, 4, 5, and then 6, and then 10, 2. Now these are all in sorted list, right? Now this one element is left with unsorted because first I have drawn here. Na, we have to keep on. This is for our understanding. Okay, I'm just splitting. This is unsorted, sorted. This is unsorted. Okay. So now you might be asking question why we are taking. So first element we need to consider as sorted. Then only we can keep on moving so that finally we will achieve that result, right? So you can take any element which is there in your question as the first element is sorted. One. Then you keep on comparing. Then now what should I do with this 2? Yeah. So what happens then? 2 will get removed and then it will go to temp, is it? So now what should I do? 1, 4, 5, 6. There will be a question mark. 10. Because when I compare with 10, it is 2 is less than. So it should keep checking again. Then it will check with the next index, that is 6. Again, it is.
1 for 5 question mark 6, 10.
Yes. So the question marks keeps on moving like this. Then here it will be inserted, right? So if you loop, so this is what happening in the for loop. So that's why I'm just writing that sequence. We can simply write it, but so now we need to implement this one programmatically. So can you tell about the logic? So I'll just complete it. Let's complete this. So what will happen here? It will be compared with 6, 1, 4, 5, question mark, 6 will be here, then 10. Then again I'll compare with 5. Still it is less than 5. So 1, 4, there will be a question mark. 5 will be moved here, and then 6, 10, then 1, 4, 5, 6, and then 10. Then it will be compared with 1. But 2 is greater than 1, so it is false. So it should be inserted there itself, right? So 1, 2, 4, 5, 6, and 10. So this is how it happens. This is the answer. These are the steps you need to show for insertion show. You just want to remember. So we are inserting wherever those elements, satisfy the condition. I mean, in sorted order, right? So we are here. I'm just showing like how you are shifting, how these elements are moving, how these elements are sorted. This is how we sort in the cards also. Na? For example, you have these many cards in your hand. Then you have got number 2. First you will say this one, this one, this one, and then you will insert. So that's what we are doing, performing here. So so this is what the logic. Can you go through this and let me know what is happening here? So guys, is there any queries in this example? So how I'm performing insertion sort? Do you understand what I'm doing? First, you need to take the first element in sorted list order. Then the rest of the elements you have to consider as unsorted list. Then you have to keep on, if the right element is less than the sorted element, then you have to move. You have to swap basically. See, in all the sorts we will perform swap. We will sort and then we will swap, right? But if you do directly a swapping, then all sorting algorithms are like bubble sort. Always we are comparing and then we will swapping. But there should be some differences, right? So we have small differences in this. So here we are not immediately replacing it. We are keep on comparing. So in this particular loop will be keep on incrementing. In the left side we will keep on decrementing. So you can see that one here. Again, I'm performing swap. You see this here, same code, right? But in bubble sort we will have for loop, and then we will have another for loop, right? For iteration, within that for loop we will swap, is it? But here it is not. Why? So I have first outer loop, the for loop for iterations. For the number of steps, na? For these steps, first, second, third, these steps. And for comparison, I'm comparing, for example, 1 with 12 like this, right? For this, I have a while loop over there. While condition like this here. So here I have assigned j equal to I, which means what happens first time? I value is 1. Why I'm starting with 1? That's the question again. Why do I start I value with 1? Because first element I myself consider it as sorted. That is 0th index is sorted. I want to compare from the first index, right? So that's why I'm starting I value with 1. Okay. Then I'm saying that. Then you know that I said that if you have n number of elements, you have to do n minus 1 comparisons. Right? Yeah. That's what. So if you have 6 elements, then you just want to compare. You just want to sort 5. So the last element will be sorted automatically. That's the logic. Okay. So here j equal to I in the sense 1 will be what is the I value? That is 1. Right? So 1 greater than 0. J greater than 0, and array of j minus 1 means 1 minus 1 will be 0, which means 0th index. In 0th index we have 5, right? In this example, in 0th index we have 4, right? Then what happens if that is greater than array of j? In array of j, what happens? What is array of j now? 1. 1. So what I'm saying, 0th index is greater than that first index. Is it greater? 4 is greater than 3 or what? 4 is greater than 3. Then what happens? What should be done? Then swap it. Is this logic is understandable or what? So this is how. But in bubble sort, we will start with from the 0th index onwards, because we have to compare from the starting element with the next element, and once that what do you call that index value is greater than, then we will swap. But here, then we will not reducing anything. We will keep on going. You see this? Here we have I++, because I have to do multiple iterations, keep on going on. But there, in insertion sort, what we are performing, in the left side we need to keep on reducing, na? So that's why I have written j minus here. At the end, after swapping, you should go and compare the left side one, keep on. So that's why it is j minus. Over there we won't do this. So that's the difference here. Right? So after swapping j minus in the sense, what happens? Yeah. Huh? Where is? Ah. Yeah. No, bubble sort also we use temp. I mean, there is a temp variable. I mean, you see this. Yes. Yeah. So we are comparing, j over there. Where? In while. Yeah, we are just, that is just checking condition, right? If it is greater, then you just swap, else don't swap. Do j minus and go. Right? So, I mean, sometimes you don't want to swap. You have a 4 here, you have 5 here, compare. Do you want to swap? No, the condition will be failed. So it will come out. It will come out of this loop, huh? It will come out here and then it will go and increment the I value. Right? See, I'm just taking here. So this stops your unwanted comparisons. Yes or no? Right? If not, again it should be, it should have to swap, and then unnecessary steps will be incremented. So that's why I'm just comparing over here itself. If it is not true, I have 4 here and 3 here. So it will be compared. 3 is greater than 4 or what? 3 is not greater than 4. So don't swap. Don't go inside. Just come out. That's why it is while, it's not for. And yeah, if the condition is true, then perform swap. Else, skip this one. It will come out here. Then it will go to this follow. Increment I value. Then it will be 2, na? 2. Now it will go to the second index. Then second index will compare with the third one. Like that, it goes on. Right. So you just want to implement this one in the lab. I think you might have done with bubble, but while inserting, while performing this insertion sort, try both the things and see the difference. And after learning the remaining 2 sorts in one program, try to implement all these things. I mean, change the program with the same sequence of numbers and see how much fast it is. In code blocks, you can see that one. If you run a program, after execution in the command prompt, it shows in the last line 0.01 seconds. So you can compare the algorithms, how fast it is. For the same set of this sequence, 5, 4, 10, 1, 6, 2, this is my input. So I'll give this one in insertion sort. Then I'll run. I'll see how much time. I'll run the bubble sort program with the same input. See that one. So like that you can compare. So which is faster? More importantly, you need to compare. You need to know this logic. Take 4 things in 4 different screens and see the you can insert breakpoints also. You know how to do that, breakpoints? I'll let you know in the next session. You can see the execution, how it is looping. For example, in a coding, I have 50 lines of program, but I want to know how this program is executing step by step. Because so here you have a query, right? Whether it goes inside the loop, it will perform swap or not. So you just have click on the line number. It shows some break pointer. then you just debug the program. So it starts, and if you debug, it starts executing step by step. When it comes to this line, if the condition is true, then it will go inside. If not, it will directly go, it will highlight this line. It is going here only, not reading this part like that, so that you can understand that. So in every IDE it is there. This option is there. If you want to know how the program is flowing, then, for example, if you have called some function here, the function is there somewhere in my program in 100th line, then it will automatically jump to the 100th line. It shows a line, red line will be there. So it is right now it is reading this particular line like that, right? Fine. So, so for selection short, again, it's the best case is big O of n square. Everything is same, but we used to write big O, but here mathematically for best case we used to say this is omega. There are three symbols: omega, theta, and what do you call that? O. But you can use big O for all. Okay. But you should know, I mean, there are these three. These are all mathematical derivations, like which while introducing these algorithms, they have found that these algorithms are best in this case. So which means why it is n square or n in the sense, for example, we are doing multiple comparisons, right? n-1, n-2, n-3 in the program I'm talking about, for loop. n-1 we are saying first time it will be n-1, second time it will be n-2, third time it will be n-3. So it keeps on going if you have a lengthy list, right? So which means that if you if you take a common values in that, n into n-1 by 2, that's the formula will come. Then you will multiply n inside n square minus 1 by 2. Then finally you will get n square. That's why it is n square. Okay, so this is the thing you will learn. But I'm just saying, the mathematical steps are there for that. Okay, so selection short is very important and very easy. So again, can you figure out the logic which I have used here? Don't think this is stack. This is again array, but it was written. So this is my question. Okay. So what is done here in the first pass? So I have put 3, 6, 1, 8, 4, 5 these elements in array. Okay. What has been done in the first pass? 1 is moved to the top, right? Why? Yeah. So that's the thing. So in selection short, you just want to find the minimum number from the whole array. Then, so see, this is my question, right? So from this, what is the minimum number? 1. So replace that one to the index. So I have replaced 1 here, right? And then 3 will take. I'm just swapping. Okay. Then now leave this part. Leave this one because it has reached the position. So now we have a 6, 3, 8, 4, 5. Out of these 3 elements, which is minimum? So out of 6, 3, 8, 4, 5, 3 is minimum. Then replace it, right? So 3 will come here. Now these two things are sorted, right? So rest is 6, 8, 4, 5. 5 or 6? Yeah, 5. I can see here. So 6, 8, 4, and 5. Then you just compare these 4, find the minimum of this one, and replace. Like that, it should continue. So, see, guys, what I'm saying is that so these are all elements. So I just want to find the minimum number from these elements. 3, 6, 1, 8, 4, 5 is there, right? So 1 is the minimum number, right? So I just want to swap. Then 1 is swapped. So the rest of the elements 6, 3, 8, 4, 5. Out of these elements, I need to find again the second minimum number, right? I mean the minimum number again. So it will be swapped. So like that, you have to keep on swapping. So I'll just tell 9, 3, 1. So can you do an example? Yeah, so these are all the elements. So what should I do first? So what is the minimum number from this? 1. So what should I do? Like this, right? 1 should replace here, na? Yes. So 1. So 1, 9. Sorry. Wait. 1. Yeah. This is what you happen when you dance. Yeah. Then 4, 2, 7, 5. Okay. Then you have to find the minimum number from here. So what happens again? 2 and what? So I want to replace like this. So 1, 2, 9, 4, 3, 7, 5. Again. So I just left with these elements. Then what is the minimum number of these elements? 9, 4, 3, 7, 5. 3. So see, logically, if you see that 9 is keep on going, right? So if I say 3, 3 should come here, is it? Right? So 1, 2, 3, yeah. Then 3, 4, here 9, 7, 5. So I have changed this question, is it? I mean, I have put 9 over here. So I'll just compare starting from that. 9, 7, 5. Again, swap. That's it. So it will be like 9, 7, 5. So 5 is the smallest. So I will just swap. So 1, 2, 3, 4, 5, 7, 9. So how many swaps we have done? We didn't do for one element. N minus 1 only we have done because last element is already sorted. Yeah. So this will be the answer. So this is very easy, right? Selection sort. Just find the minimum and swap. So yeah, actually bubble sort is very lazy. I mean, when you compare with selection sort, theoretically it is 4 times lesser than, less performing, and 2 times less performing than insertion sort. When you compare bubble sort, it is 2 times less than insertion sort, 4 times less than selection sort. But we have tried yesterday in the lab, like we compiled the same program in Visual Code Visual Studio Code, and we executed the same program in what do you call that? Code blocks. But when you run 2 programs, bubble sort and selection sort in code blocks itself, so bubble sort is taking a lot of time and selection sort is taking less time than bubble sort. Okay, so there is some timing now. For example, 0.05 is there in code blocks, but in Visual Studio the same is happening, but execution of bubble sort is taking more time, and insertion sort is also taking more time, which means it depends on the compiler, but the concept is same. Bubble sort is less efficient than other algorithms, but in Visual Studio it shows it is taking like 10-15 seconds extra because the IDE was heavy, and that's why. But again, when I run bubble sort, insertion sort in Visual Studio, again bubble sort is slow, but the time taken, I'm talking about the speed, the execution speed of that particular IDE is slow when compared to code blocks, because code blocks is specially designed for only this purpose. In Visual Studio you have got a lot of extensions, a lot of packages are there, so that's the reason. But you can try it in anything. You can check the speed. So now what is the logic for this selection sort? What will be the logic? Right? So again, I need 2 for loops. One is for iteration, one is for increasing the passes. Then the first loop is for passes. Then in the second loop, I need to compare. So in the second loop, what I'm doing? Second we will do n minus 1 the passes, right? And here I'm comparing with here so we need to find the minimum number now always. Selection short is about that. Do you agree with that? So we use one variable that is called min. For understandability, I am taking that min. So now min is I. Min equals I, which means what will be the value in min? What will be the value in the min? Min equal to I say. That is 0. Because I put 0 here. So min is 0. Then I'm saying that say I want to compare with I plus I0 plus 1 is 1. Right? I mean first index. So which means that here what is the value of say? Say is 1. A equal to I plus. Yeah, I is 0 right now. I equal to 0 now for the first instance. 0 plus 1 is 1. Right? So array of say which means that it goes to 0 index, right? So it's first index. 0 plus 1, 0 plus 1 is 1. So it goes to the first index. Now I'm comparing first index less than array of min. What is min? Min 1 is 0. Yeah, 1 is 0. So I'm see, I want to compare this first index with this one. Right? So and then what happens? Yeah. So we need to find the minimum number. Then here we will start. Okay. The starting is same in all the sorting things. So this is how it goes. Right? But logically we have solved in that way. We need to find the minimum number when we are sorting. But programmatically you need to solve based on index only. So the array of I have written like this now. Which means here the J value is initially it is 1. Here min value is 0. Now basically these two things are compared. 0 and 1. So which is min. If they are same less than what do you call this? Min. If it is less than 9 is less than 3 or what? Greater than. So this won't execute that. Then it will start here. Right? So which means this will be start. So when the condition is true, then the min value will be set, then it will come out and then it will start. If the condition is false, then it won't set min equal to 0. Because in the next step, we don't want this for loop to unnecessarily compare all the elements. Once you find the minimum number, you keep on swapping and go out. So you want to try these two logics in your lab, so experience it, like how it is working, and we just left with 2 more sorting algorithms and 2 searching. Yeah. Yeah. Here. Yeah, them. They have five again. Yeah, you're right. You right equal condition and mean them equal to five. It was the mean were I. Now I'm saying now here I have assigned the mean equal to the J. It means what happens? J value will be assigned now. So it means now min is 1. Then to be changed because earlier it was 0. Now here I have changed. Then I'm just making those things here. I'm assigning the min value to I. Then I'm assigning the min value to 10. As I said in previous example, we have cards such that it is 1. Right? That's why I said that. Right? Practice the program and insert breakpoints wherever you want. You can insert multiple breakpoints in a program. Red dot. So execute this line. Then after executing this line, you want to know whether it is going inside this condition or it is going directly here. Then you will get the concept, right? That's why I'm saying that insert breakpoints. Right. So, is there any queries then? These 3 concepts you have to try in the lab, right? Definitely. Bubble shot, insertion, selection, and we have merge, and one more. What is it? Yeah, quick shot. So quick shot is not quick shot. The name is quick shot. We will see that one in the next class. It's a little bit lengthy than this. So I'll go for attendance. Please do answer attendance.